They're all measured in terms of watts or kilowatts. Displacement cannot be zero because they are magnitude values of force and displacement. F dot S divided by T. What is the probability of getting positive work done? Work done is defined as force into displacement by time. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram, Pre-University, Mysuru. Continuing my session on the topic work, power and energy. In my previous session, we have discussed a very important law called as the law of conservation of mechanical energy, and we have proved the law in case of a freely falling body. We have discussed topics like coefficient of restitution and understood the differences between elastic and inelastic collision. Continuing my discussion today, we will study a few consequences of whatever is done earlier in this chapter. Now, dear students, recalling the definition for work done by a body, we told W is vector F dot vector S. So it is a dot product. And if you remember, therefore, by expansion, W is F, S, cos theta. Therefore, we say here force and displacement are vectors. Vector F and vector S. They are vector quantities, but their dot product, which is work done, is a scalar. Very important to remember. The result of the dot product of two vectors is always a scalar. So here, force and displacement are vectors, but the result of their dot product, work done, is always a scalar. So point 1 to remember here, the result of the dot product of two vectors is always a scalar. The result of the cross product of two vectors is always a vector. Now, so again, W is vector F dot vector S. On expansion, it is F, S, cos theta. Now I assume when the angle between force and displacement is 90 degrees, andre when theta is 90 degrees, what is the value of cos 90? Beautifully 0, which means work done also becomes 0. I told F cannot be 0, force cannot be 0, displacement cannot be 0 because they are magnitude values. So if theta is 90 degrees, cos 90 is 0, which means the work done in this case is 0. Consequently, to say that no work is done when force and displacement are at right angles to each other. Theta being 90 degrees andre, force and displacement are at right angles to each other anta artha. So, no work is done if force and displacement are at right angles to each other. Therefore, a person carrying a load on his head, if a person is carrying a load on his head and walks on a horizontal surface, ಎಷ್ಟು ಕಷ್ಟಪಟ್ಟು ಒಂದು ಲೋಡನ್ನ ತಲೆ ಮೇಲಿಟ್ಟು ಹಾರಿಜಾಂಟಲ್ ಸರ್ಫೇಸ್ ಮೇಲೆ ವಾಕ್ ಮಾಡಿದ್ರೆ ಸ್ಟಿಲ್ ವಿ ಸೇ ದೇರ್ ಇಸ್ ನೋ ವರ್ಕ್ ಡನ್ ಬೈ ದಿ ಫೋರ್ಸ್. He is toiling so much, but still the resultant work done is 0. Why? Because in this case, force and displacement are at right angles to each other. In this case, theta is 90 degrees. Therefore, we say there is no work done by that person. Now, when do you say work done is positive? What is the probability of getting positive work done? Work done is positive when force and the component of displacement, or in simple terms, force and displacement are in the same direction. If the force acting on a body displaces the body in the same direction of force, then we say for work done is positive. So when is work done positive? When force and displacement are in the same direction. Now, as a result here, work done by the force on a body, where the body gains energy. If we are doing work, positive work, we say the body gains energy. And when is positive work said to be done? Force and displacement are in the same direction. Force acting on a body displaces the body in the same direction. Then we say work done is positive. Then the other way, when is work done negative? When force and component of displacement are in opposite directions. If the force and displacement happen to execute in opposite directions, force acting on a body displaces the body opposite to the direction of the force, then the work done is negative. And here the body loses energy. So dear students, whenever work done is positive, the body will gain energy. And whenever work done is negative, body will lose energy. Total work done by a number of forces is the integral of work done by all the forces or work done by the resultant force. Whatever total work done by a resultant force can be defined as the sum of the work done by the individual forces or the components of that resultant force. So students, very important, work done is positive if the force acting on a body displaces the body in the direction of force, and here the body is gaining energy. Work done is negative if the force is displacing the body opposite to the direction of the force. Here work done is negative and body loses energy. Total work done by a resultant force is the sum of work done by individual forces. Now going to the next topic. Again, a significant topic, what is called as power. We define power as time rate of doing work, or rate of doing work is called power. So in simple terms, power is defined as work done divided by time taken, rate of doing work. Time rate of doing work, or power is work done by time taken. So power is W by T. But what is work? It is the dot product of force and displacement. So we write P is F dot S divided by T. Work done by time taken. Work is the dot product of force and displacement, F dot S divided by T. And what is displacement by time? Displacement by time is velocity. Therefore, power is F dot V. Many a times asked to prove in the exam that P is F dot V. So we say power is the rate of doing work, work done by time taken. P is W divided by T. Work done is defined as force into displacement by time. Displacement divided by time is velocity. So P is F dot V. Now, the particle moves with a constant velocity when the force overcomes the frictional force. Friction is actually a barrier for motion, and any particle is said to move with constant velocity, same velocity, if the applied force just resists the frictional force, or if the applied force is overcoming the frictional force, then the particle is said to move with constant velocity. Now, units of power. So we have power is work by time. SI unit of work is joule per second, but the accepted unit is watt. So the SI unit of power is watt. 1 watt is said to be 1 joule per second. Andre, we say if a work of 1 joule is done in 1 second, 1 joule of work is said to be done in 1 second, then the power established is 1 watt. So 1 watt is 1 joule per second. Power of a system is said to be 1 watt if a work of 1 joule is said to be done in 1 second. The power consumed by electric appliances is always measured in watts or kilowatts. 1 mark ge yavaglu keltiridina. The power that is consumed by electrical devices, heaters, electrical cookers, geysers, they're all measured in terms of watts or kilowatts. For any automobile or motors, power is always measured in terms of horsepower, and 1 horsepower is always 746 watts. So this completes the theoretical session on this chapter, students. In my next session, we will bring up with numericals, practice the theory, go through the chapter. It will help you to understand the numericals better. Until then, have a nice time. Thank you.